If you were to somehow, I don't know, transport a massive, incredibly hungry polar bear and just drop it squarely into a bustling colony of thousands of
Yeah.
completely defenseless penguins.
Oh, which sounds like a total bloodbath waiting to happen.
Right, you'd think it would just be an immediate feast. But the wild thing is, the bear probably wouldn't even recognize them as food. It would most likely just look incredibly confused.
Yeah, it would be totally bewildered.
And today, for our deep dive, we are looking at exactly why that is. We're exploring one of the greatest geographical and biological divides on Earth, trying to understand the strict evolutionary boundaries that separate the predators of the North Pole from those communal bird colonies of the South Pole.
It's a fascinating topic, and honestly, the source material we have for this rigorous scientific breakdown might actually surprise you.
Oh, it's definitely going to surprise them.
Yeah.
Because, usually for an audience like you who tunes in for these really deep technical explorations of how our world works, we're looking at dense, peer-reviewed journals.
Right, with the satellite data and, endless Latin classifications.
Exactly. But today, our core facts are coming from a brightly colored children's book. It's called Jonty, Gentoo, written by Julia Donaldson.
Which, it completely subverts expectations, right?
It sounds completely counterintuitive.
It does. But this book is essentially a biological Trojan horse.
Mm.
It disguises this incredible masterclass in polar geography and, well, marine biology and evolutionary isolation, all tucked inside this rhyming story about a runaway zoo penguin.
Yeah, and the author clearly understands that compelling fiction, even if it's meant for toddlers, it requires a world that's governed by strict real-world laws.
Exactly. Without an accurate biological baseline, the protagonist's journey, it just carries no real weight. So by analyzing the specific obstacles that are thrown at this penguin, we can actually reverse engineer a highly accurate map of global marine biomes.
Okay, let's unpack this. Our baseline is established pretty much immediately in the story. We meet Jonty, who is a Gentoo penguin living in a zoo enclosure.
Right, he's totally separated from his natural habitat.
Yeah, and he's listening to his aunts. They're passing down this generational knowledge about a magical land where, as they say, the sun shines all night and all day, a place just covered in snow and ice.
And right there, they are describing the extreme photoperiodism of the Antarctic summer.
Wait, photoperiodism?
Yeah, it's basically how organisms respond to the length of day and night. Because of the Earth's axial tilt, the South Pole is exposed to 24-hour daylight during its summer. But, Jonty is stuck in a temperate climate.
He's cut off from his ancestral home.
Precisely. And that separation is the catalyst for this entire biological mapping exercise we're going to do today.
So he squeezes through a gap in the fence at midnight, and he heads for the sea. But what I love is that the text doesn't just, cut to the next scene with him magically standing on an iceberg.
No, not at all. It forces him to actively cross distinct ecological zones.
Yeah. He swims for weeks. He sees all these incorrect poles. Flag poles, barge poles, tent poles, before he finally hits the actual ocean journey. And his diet during this massive transglobal, all-you-can-eat seafood buffet road trip is super specific.
It really outlines a shifting marine food web based on global thermal gradients.
Right, because he starts swimming and his diet shifts rapidly. The text specifically notes he eats cuttlefish and jellyfish first, then he moves on to codfish. And finally, as the water gets dangerously cold, he hits krill.
He is essentially eating his way down the thermometer.
But wait, is it actually biologically sound for a penguin to be eating this specific variety of sea life on a single journey? This prompts a huge physiological question for me.
Oh, like what?
Well, he's swimming through these distinct thermal layers, right? Tracking changes in marine populations. So what does this all mean for his own biological thermal regulation?
Ah, I see where you're going with this.
Because a penguin is heavily insulated. They've got those densely packed feathers and a really thick layer of blubber designed for, absolute freezing temperatures.
Yeah.
If he starts in a temperate zone and has to cross the equator to get to the poles, wouldn't his internal metabolic engine just totally overheat and shut down?
That is a phenomenal point, and it speaks directly to the behavioral adaptations of marine animals. A heavily insulated penguin crossing equatorial waters would absolutely face lethal hyperthermia if, and this is the key part, if they stayed at the surface.
So they don't stay at the surface.
Right. To survive that crossing, a penguin would have to rely on a deep pelagic diving. The surface water might be warm, sure, but if you dive just a few hundred meters down, you hit what's called the thermocline.
The thermocline?
Yeah, it's this transition layer where water temperatures just drop drastically. So he would be using the ocean's vertical temperature layers to manage his core heat while he's hunting those deep water cuttlefish and jellyfish.
Wow, okay. And then as he moves into the higher latitudes, the surface water itself starts to cool down.
Exactly, and that's when he encounters the codfish, which prefer those chilly but, not quite freezing mid-latitude waters.
And then eventually he gets to the absolute foundation of the polar ecosystem, the krill.
Yes. What's fascinating here is how krill acts as the crucial biological threshold in this journey.
Like once you hit krill, you know you're in the freezer.
Exactly. These tiny crustaceans are not just incidental to cold water, they are biomechanically engineered to dominate it. When Jonty starts eating krill, we know for a fact he has crossed into frigid polar waters.
Because normal marine life would just freeze, right?
Yeah, temperatures that would freeze the cellular fluid of most marine life are fine for krill. They possess specialized cold adaptation mechanisms. They actually graze on the algae that literally grows on the underside of the sea ice.
That is wild.
It is. They are the primary energy converters of the entire polar biome. They turn that microscopic ice algae into a protein source large enough to sustain, well, whales, seals, and of course penguins.
Okay, so he's found the ice, he's eating the krill, he waddles onto this white frozen wilderness, and he totally assumes he's found the South Pole, his penguin utopia.
But he hasn't.
No. He waddles for weeks without seeing a soul. The sun goes away, plunging him into the total darkness of the polar night. Jonty has made a hemisphere-sized navigational error.
A very dangerous error.
Right, because he isn't in Antarctica, he is at the North Pole. And almost immediately, he is attacked by a huge bearded seal looking for a meal.
And the introduction of the bearded seal here is an incredibly precise ecological marker by the author.
How so?
Well, the bearded seal is a species endemic strictly to the Arctic Ocean and its adjacent seas. You won't find them in the south. And unlike many of the sleek, fast-swimming pelagic seals that chase fish through the open water, bearded seals are primarily benthic feeders.
Benthic meaning bottom feeders.
Right. They use those highly sensitive whiskers, their beard, basically to detect vibrations and root around on the shallow seafloor for clams, squid, and bottom-dwelling fish.
But wait, the text says the seal wants to eat him. If it's a bottom feeder, why on earth is it trying to eat a penguin waddling on the surface of the ice?
Because the Arctic winter is just a brutal crucible of calorie deficit. Predators in the extreme north, they have to be highly opportunistic.
So they can't afford to be picky.
Exactly. A strange, slow-moving bird suddenly appearing on the ice in the middle of winter. That represents a massive, completely unexpected package of fat and protein. The seal abandons its usual benthic foraging because survival dictates taking advantage of whatever calories present themselves.
Okay, but right before Jonty becomes this benthic feeder's bonus meal, a white fairy creature steps in. It terrifies the seal away and then reveals itself to be an enormous white polar bear.
The ultimate apex predator of the Arctic.
Yes. And here's where it gets really interesting. The polar bear is a hypercarnivore. It's a killing machine. Yet it doesn't attack Jonty.
Yep.
Instead, it politely asks, "How else may I help you today?" Why would a starving apex predator chase off a meal only to completely spare the penguin?
If we connect this to the bigger picture, this interaction perfectly illustrates the neurological concept of a predator's search image. And that is tied directly to evolutionary geography.
Okay, break that down for me. Search image.
So, the Arctic and the Antarctic are physically and fundamentally different. The North Pole is an ocean covered by shifting sea ice, and it's surrounded by massive land masses, North America, Europe, Asia.
Right.
Because it's connected to land, terrestrial predators, like the ancient ancestors of the polar bear, could simply walk out onto the ice over millions of years and adapt to hunt there.
So they became perfectly tuned killing machines for that specific environment.
Precisely. A polar bear's brain, its olfactory senses, its entire hunting instinct, is neurologically hardwired to recognize seals, specifically ringed and bearded seals. I mean, they can smell a seal's breathing hole through feet of solid ice. Their search image is exclusively calibrated for seals.
And the South Pole is the exact opposite.
Antarctica is a massive frozen landmass entirely surrounded by the Southern Ocean. Terrestrial land predators never had a land bridge to walk across.
So they just never got there.
Right. That geographical isolation means polar bears live exclusively in the north. and penguins evolved exclusively in the South. They are separated by tens of thousands of miles.
Which brings us right back to the hook we started with.
Huh.
The bear simply doesn't recognize the penguin as food.
Exactly. It has absolutely no evolutionary context for a bird of that size and shape just standing on the ice.
So the bear's neurological search image fails to trigger a hunting response. It looks at Jonty and sees an anomaly, not prey.
Yeah, the children's book trope of a polite, helpful animal is actually masking this profound truth about evolutionary isolation. It highlights that the Arctic is defined by solitary terrestrial predators wandering an ice-covered ocean, which is completely incompatible with the biology of a penguin.
Okay, so Jonty is trapped in a biological zone that makes absolutely no sense for his survival. But then summer comes around, bringing with it a creature that completely defies the geographical isolation we just talked about.
Ah, yes.
A gray and white Arctic tern flutters down, takes one look at Jonty and says, "You look like a penguin, but that can't be right. I've never before seen a penguin up here."
The Arctic tern acts as the ultimate biological auditor in this narrative. It immediately recognizes that a penguin in the Arctic is an ecological impossibility.
Right, because she knows better.
Yeah.
The tern offers to guide him to the South Pole, casually revealing that she visits it every single year.
It's incredible.
It is. So if this tiny gray and white bird is breeding in the Arctic summer and then flying 12,000 miles to the Antarctic summer, it is essentially hacking the planet's axial tilt to live in perpetual daylight. That requires an absolutely insane metabolic engine.
It really does. What's fascinating here is the mechanics of that specific survival strategy. The Arctic tern undertakes the longest migration of any animal on Earth. They cover roughly 44,000 miles round trip annually.
44,000 miles.
Yeah.
For a tiny bird.
Yeah. And by chasing the summer from pole to pole, they experience more daylight than literally any other creature on the planet.
But why? What is the evolutionary payoff for burning that many calories just to fly across the globe twice a year?
Well, it all comes down to photoperiodism again and foraging opportunity. Terns are plunge divers. They hover over the water and dive to catch small fish and invertebrates near the surface.
Oh, so they need to be able to see their prey.
Exactly. They rely entirely on sight to hunt. So by ensuring they are always living in an environment with near 24-hour daylight, they maximize their foraging time. They can feed continuously, which is exactly what's required to fuel a metabolism capable of a 44,000-mile flight.
It's basically a solar-powered engine. It surfs the Earth's orbit around the sun to ensure it never has to experience the calorie-draining darkness of polar winter.
That's a great way to put it.
But while the tern makes this massive planetary commute look effortless, our penguin really starts to break down. They travel together, but the text notes Jonty's flippers get incredibly sore, and he eventually has to hitch a ride on a passing boat with some sailors.
Which includes a man in a bright yellow coat, a nice little detail.
Yeah, so what does this contrast mean? How can the tiny bird do it, but the penguin has to become a sailor?
It's a stark contrast between avian flight stamina and marine swimming stamina. Avian anatomy, like the terns, is optimized for sustained, low-resistance travel through the air. They have hollow bones, highly efficient respiratory systems.
Built for the sky.
Right. A penguin, conversely, is built like a torpedo. They have dense, solid bones to overcome buoyancy, which allows them to dive deep. But swimming through water, which is hundreds of times denser than air, requires a massive output of kinetic energy.
So they just can't keep it up for a global commute.
No. While they are master navigators of the ocean, asking a dense, heavy penguin to swim the entire longitudinal span of the planet in one go, it pushes their biomechanics way past the breaking point.
So the boat provides a narrative shortcut, but it actually mirrors reality. I mean,
Yeah.
human research vessels and icebreakers are often the only things besides the terns crossing those extreme latitudes.
Very true.
And this vessel finally drops Jonty at his actual home, the Antarctic. And immediately, the text hits us with this staggering visual contrast to the lonely north. The shore is packed with, as the book says, black, white, and orange penguins galore.
This raises an important question about how ecology dictates social structure. We established earlier that the North Pole was isolated and predatory, right? The bear and the seal were solitary creatures hunting on a shifting ocean.
Right, very lonely, very dangerous.
But the South Pole is depicted here as a place of staggering abundance and dense community.
So why is the Antarctic able to support these massive, totally defenseless colonies just hanging out on the open ice?
It has a lot to do with the physical geography we discussed, but even more importantly, the oceanography. Antarctica is surrounded by the Antarctic Circumpolar Current.
Like a giant river in the ocean.
Basically, yeah. It is a massive, incredibly fast-moving current of freezing water that endlessly circles the continent. It acts like an impenetrable thermal and physical moat.
A moat.
Yeah. It keeps warm water out, locking the continent in a deep freeze, and it prevents those terrestrial predators we talked about from ever reaching the ice.
Ah, so because there are no land predators, penguins can gather in these colonies of hundreds of thousands to breed on the open ice without any fear of being hunted from the land.
Exactly. They traded aerial flight for deep ocean diving because they simply didn't need to fly away from bears or foxes.
That makes so much sense. And the author doesn't just lump them all together as generic penguins either. She catalogs a highly stratified society, which really demonstrates the competitive exclusion principle.
Because if all these penguins lived and hunted in the exact same way, they would compete themselves into starvation.
Right, so they carved out very specific ecological niches. The book categorizes three distinct types. First, we see the emperor penguins, which the text calls majestic and tall.
Emperors represent the extreme edge of adaptation. Their immense size reduces their surface area to volume ratio, which conserves heat. That allows them to actually breed during the brutal depths of the Antarctic winter when the ice is most stable.
Wow.
And they also possess high concentrations of myoglobin in their muscles. This stores oxygen so they can execute crushing, deep ocean dives that are just far beyond the reach of the other species.
Okay, so then Jonty passes the Adelie penguins. The book notes they are quite sweet but too small.
Right, so the Adelies occupy a totally different niche. They are much smaller, highly active, and heavily dependent on the sea ice. They don't dive nearly as deep as the emperors.
Or do they hunt them?
They forage in the shallower, highly concentrated zones of krill that congregate near the edges of the pack ice. Their smaller bodies require less total food, which allows them to thrive in these densely packed, almost chaotic colonies.
Okay, and finally, Jonty finds a heartwarming huddle of his own kind, the Gentoos, and they politely queue up to say, "How do you do" to him?
Gentoos are highly adaptable. They often forage much closer to shore, and they actually breed on ice-free patches of land.
So you have this incredibly dense, specialized ecosystem all living together. You've got the towering emperors in the deep ocean, the speedy Adelies at the ice edge, and the bright-beaked Gentoos dominating the coastal shallows.
It's a perfectly balanced biological engine, entirely protected by that moat of ocean currents.
And then to close the loop, the narrative jumps forward half a year. The Arctic summer approaches again. The Tern leaves the Antarctic penguin colony, flies all the way back north to the realm of the polar bear, and actually stops by the zoo to update Johnny's aunts.
The Tern completes the cycle. It proves that while it belongs to both worlds, the apex predators of the Arctic and the specialized bird colonies of the Antarctic are just forever locked in their respective deep freezes.
It's genuinely astounding to realize that a whimsical rhyming book meticulously maps out thermal gradients, neurological search images, the mechanics of photoperiodism, and ecological niches.
It really proves that giving a story actual biological stakes and factual accuracy, it doesn't diminish the magic of the narrative at all. It elevates it. The strict division of global biology is literally what drives the entire plot forward.
It really does. So for you listening at home, I want you to keep this in mind when the winter holidays roll around, because you are absolutely guaranteed to see a greeting card featuring a cute illustration of a polar bear and a penguin hanging out on an iceberg together.
Maybe they're sharing a scarf or, a cup of cocoa.
Exactly.
Yeah.
A charming image, but an absolute evolutionary and geographical impossibility.
Completely impossible.
And now you know the actual science behind that fallacy. You know that an entire planet's worth of thermal gradients, impenetrable ocean currents, and hardwired neurological search images actively prevent that meeting from ever happening.
The only way a penguin and a polar bear ever cross paths is if one of them completely ignores its thermodynamic limits.
Right, eats its way through thousands of miles of cuttlefish and krill and lands on a frozen ocean where it fundamentally doesn't belong.
It really invites a much closer examination of the media we consider simple. When creators take the time to embed accurate trophic levels and evolutionary history into a story meant for toddlers, it just demonstrates this profound respect for the natural world and really for the audience.
It makes you wonder what else we are missing. How many other incredibly specific, scientifically rigorous masterclasses in the physics or biology or history are just sitting there on a nursery bookshelf.
Disguised as a simple rhyme.
Exactly, just waiting for an adult to actually pay attention to the rules of the world being built. So the next time you find yourself reading a bedtime story, remember, the complex truths about how our planet functions aren't just locked away in dense academic journals. Sometimes they're wearing a bright yellow coat and hanging out in a heartwarming huddle of Gentoos.